Okay, so let's take a quick look at the anatomy of a hurricane. So now we'll just call them hurricanes for this slide, even though we know that they're generically called tropical cyclones. So probably most notable would be those spiral rain bands that we can see from satellite images or an aerial view. So spiral rain bands, we're going to see that actually the rain is what has the most effect on taking lives, that large amount of rain that comes inland. So with the rain bands, actually we have, well, let me start here. As with a lot of weather systems, we have a connection between what's happening at upper elevations and what's happening at lower elevations. At the lower elevation here, we have actually a low pressure, and at the upper elevations, we have a high for the same for the hurricane, the storm itself. So around the low, actually, if you look, you can see it going counterclockwise around a low. That's my counterclockwise. And around a high, it's actually going to go clockwise. So we're going to see these spiral rain bands associated with kind of what's called the outflow of the storm going in a clockwise motion. So that's already kind of weird. What else we got? We have the eye of the storm, which if you've ever heard that the eye is, if you're aware the eye is, actually it's calm inside the eye. Is that not creepy or what? But just step outside the eye and you get to what's called the eye wall. And the eye wall is the most intense part of the storm. It's got the most intense precipitation. We're going to see actually that oftentimes there are tornadoes embedded in these thunderstorm cells that make up these weather systems. So it's got that going on, and it's got the most intense wind. This down here actually is showing you kind of a pressure. It's showing you the pressure, and it's showing you the wind. Okay, so the deal here is, here we have the pressure getting less, pressure dropping. The pressure drops very steeply right here at the eye wall. And that steep pressure drop actually creates these crazy these crazy winds. Here then it kind of levels out at a very low pressure in the eye of the hurricane, and here then after the storm, here then as the storm passed these measuring devices, then we get to the eye wall again, where the pressure increases quickly and we have crazy temperature, or excuse me, crazy wind speed again. So, So then another thing, in addition to the spiral rain bands, we have this kind of ongoing outflow. Again, at the upper elevations for a hurricane, there's a high pressure up there, so that would be going clockwise in the northern hemisphere. So if you want to create a hurricane, good luck. No. Things that scientists monitor for conditions ripe for hurricane formation include warm water. And so actually, as we look at global warming, all temperatures are increasing, including the temperatures of the seas. Now, water is stubborn to heat up, so it's going to be a little bit of lag between our global warming and our sea surface temperatures increasing, but they are. Another factor is spin. And we talked about the Coriolis force as what we call an apparent deflection, because the Earth is spinning on its axis. And that's actually what gives us our cyclonic and anticyclonic movement around these big weather patterns we call, around a surface high and a surface low pressure. But for hurricanes, they need a certain amount of spin. And I don't know if you remember, but we said that the Coriolis force is 0 at the equator and most noticeable at the poles. So here we have a little bit of a conundrum, because they need warm water, but you can't get too close to the equator. So it needs to be at least 5 degrees on either side of the equator in order to get enough spin for this weather system to work. And then the last one is the air needs to be sufficiently unstable. Now, in this sense, unstable, we're talking about basically the tendency of the air to rise. And most notably the warm, again, the warm ocean waters give you that boost for it to go ahead and have what we call convective lifting, and that is oftentimes the case on our eastern coasts of continents. So having unstable conditions on the west is really usually not, on western side of continents, is not suitable for hurricanes.